Covalent bond given by Lewis. Equal contribution followed by equal sharing of bond pair of electrons is called covalent bond found between two bonded atoms or two bonded groups. Example, H, it has one electron. Another H atom has one electron, so bond is formed, equal contribution. After the formation of bond, this bond pair of electrons belongs to this H atom as well this H atom belongs to both. It means equal contribution, equal sharing. Covalent bond is formed between atoms of the same non-metal. That bond is pure covalent bond. H bond H, F bond F, Cl bond Cl, O double bond O, N triple bond N, P4, S8. If the bond is formed between atoms of two different nonmetals, for example HCl, then this bond is called polar covalent bond. This polar covalent bond is formed between H bond Cl, H bond F, N bond H, O bond H, so on. And actually between the two nonmetals, the electronegativity difference is less than 1.7. Such a bond is called polar covalent bond. H atom has one unpaired electron. Another H atom, one unpaired electron. Formation of bond. So this pair of electrons belongs to this H, that is 2 electrons. This pair of electrons belongs to this H, 2 electrons. Both have attained stable helium configuration. Likewise chlorine, 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. Another chlorine atom, 1, 2, 3, 4, 5, 6, 7. So this single bond. Now it has octet and it has octet, 8 electrons each. So bond pair belongs to both. Likewise oxygen molecule, oxygen 1, 2, 3, 4, 5, 6. Another oxygen 1, 2, 3, 4, 5, 6. This unpaired electron bond, this unpaired electron bond. Now oxygen has got totally 8 electrons, even this oxygen also has got 8 electrons totally. Likewise N, 5 valence electrons, 1, 2, 3, 4, 5. Nitrogen 1, 2, 3, 4, 5. So bond pair. So nitrogen has got octet. Likewise ammonia, NH3, N has 5 valency electrons and each H contributes 1 electron. So 3 H's. So we have totally 5 valency plus 3 extra electrons from 3 hydrogen atoms, totally octet. This representation is correctly called Lewis dot formulae. Properties of covalent compounds. Covalent compounds are mostly gases which include methane, etc., having low melting points and low boiling points. Since here the forces acting among the molecules are weak van der Waals force of attraction. And covalent compounds are non-polar in nature. For example, iodine. So both are iodine only 0, 0. No positive pole, no negative pole. Hence it is non-polar. As non-polar, it is soluble in non-polar solvents such as carbon tetrachloride. So covalent compounds are non-polar in nature, hence they are soluble in non-polar solvents such as carbon tetrachloride, benzene, etc. And covalent compounds, they are held by strong bond, no free electrons, no conduction. So covalent compounds do not conduct. But graphite, even though it is covalent, here it is bonded with another 3 carbon atom, central atom, one pi bond. That means pi electrons, free electrons. Because of this free pi electrons, graphite, even though it is non-metal, even though it is covalent in nature, it conducts electricity. It acts as conductor. Among the covalent compounds, reactions are very slow since they involve bond fission, then only chemical reaction. Hence, reactions are slow. Covalent bond, it is directional. Coordinate covalent bond or so-called dative bond given by Lewis. Suppose we have two atoms or groups, say A and B. A is having vacant orbital. B is having non-bonding pair of electrons, so-called lone pair of electrons. B acts as electron pair donor and A acts as electron pair acceptor. Required pair of electrons for the formation of bond is supplied by B. Hence it is called electron pair donor, and A is correctly called electron pair acceptor, and the bond formed between these two A and B is called coordinate covalent bond or dative bond. By definition, it is the bond formed by contribution of pair of electrons by one of the atom or group followed by equal sharing of bond pair of electrons is called coordinate covalent bond or dative bond. For example, NH3, N has 5 valence electrons. Out of 5, 3 valence electrons consumed in the formation of 3 bonds. It has lone pair of electrons and H plus ion vacant orbital. So, electron pair donor, electron pair acceptor, coordinate covalent bond, that is NH4 plus ion. Ammonium ion is formed. Similarly, oxygen, after formation of 2 bonds, that is water molecule, here oxygen has got 2 lone pairs. It donates 1 lone pair to H plus ion, formation of hydronium ion. And ammonia, it has lone pair of electrons, and B boron, it has vacant orbital, hence electron pair donor, electron pair acceptor, formation of ammonia boron trifluoride. In BF3 molecule, B boron, 3 valence electrons, 3 bonds it has formed, it has vacant 2pz orbital, and fluoride ion donates lone pair, that is BF4 minus is formed. AlF3, Al 3 valence electrons with 3 fluorines, 3 bonds. Similar to 2pz, aluminum has 3pz vacant orbital. In addition to 3pz, it has vacant 3d orbitals. Hence, fluoride ions, 3 in number, they act as electron pair donors and form coordinate covalent bond, that is totally AlF6 minus 3 is formed. Likewise, ferrous ion with 6 cyanide ions, electron pair donors, we have ferrocyanide. Ferric ion with 6 cyanide ions, we have ferricyanide. Silver ion with ammonia, so it forms silver diamine, Ag NH3 twice plus, that is diamine silver ion complex. Formal charge. It is an imaginary charge calculated based on pure covalent nature of bonding, mainly for polyatomic molecules. It is helpful to find out the more stable structure for the given molecule. Here, the structure with low formal charges possess low energy, hence they are stable, highly stable. Formal charge of the atoms present in a molecule calculated as here formal charge F equals to number of valency electrons minus number of bonds it has formed minus number of non-bonding electrons it possesses. Formal charge F. In case of N2O molecule, so called nitrous oxide, laughing gas, bonding is represented by here NO. N forms 3 bonds, and this N, after forming 3 bonds, N has totally 5 valence electrons. So here we have 3 bonds and 2 electrons, 1 lone pair is there, and this one also having lone pair donates to oxygen, forms coordinate covalent bond. Actually oxygen 6 valence electrons as 3 pairs. So this is the bonding in N2O molecule. So call this one as N terminal, N middle and oxygen atom. So for N terminal, formal charge. So here valence electrons 5 nitrogen and it has formed 3 bonds, and here it has 1 lone pair of electrons 2. Hence 5 minus 3 minus 2 0 is the formal charge for terminal nitrogen atom. For middle nitrogen, let us see. So 5 valence electrons, 1, 2, 3, 4 bonds it has formed, and here no non-bonding electrons, because it has given that lone pair, no non-bonding electrons. So 0. Hence 5 minus 4 minus 0 equals to 1. Then oxygen atom. Oxygen has 6 valence electrons, forming only 1 bond, and all the 6 valence electrons are non-bonding electrons. 6 minus 1 minus 6 equals to minus 1 is the formal charge of oxygen. In SO2 molecule, the central atom, sulfur atom, atomic number 16, electronic configuration neon 10, that is 1s2, 2s2, 2p6, 3s2, 3p4 and 3d0. So 3s2, pair of electrons, 3p4. In accordance with Ohm's rule, 1, 2, 3 and 4th electron is paired, and it has got vacant 3d. Now sulfur has 2 unpaired electrons forming 2 bonds with oxygen, and sulfur donating 1 lone pair to oxygen, and still it has 1 lone pair. So this is the representation of bonding in SO2 molecule. Now let us see first this oxygen, formal charge. Oxygen 6 valence electrons as such. So it has got 6 valence electrons and it has formed 1 bond, and all the 6 valence electrons as such, I mean non-bonding electrons. So 6 minus 1 minus 6 equals to minus 1. And oxygen with double bond, this is the oxygen. So oxygen out of 6 valence electrons, 4 as such non-bonding. The remaining 2 electrons participated in bond formation. So oxygen with double bond, here this one 6 valence electrons forming 2 bonds and having 4 valence electrons. 6 minus 2 minus 4 equals to 0. The middle atom, sulfur atom, 6 valence electrons forming 3 bonds, 1, 2, 3 bonds, having non-bonding electrons 2 in number. Hence 6 minus 3 minus 2, that equals to plus 1 is the formal charge of sulfur.